Okay, and here I'm going to show you how to how to sketch trigonometry graphs. Okay, well, as you all know, well, basically there are three types of trigonometry graph: y equals to sine x, y equals to cosine x, and y equals to tan x. Okay, here what they looks like. Let's look at y equals to sine x first. Okay, what you can say is a wave-shaped graph along x-axis, and they are repetitive. So, okay, basically basically they are repetitive. Say, if we take the part from 0 to pi, it's like we call it a period, or you say a completely cycle of the graph. If the next part will be exactly the same thing, and if as your x value increase into infinity, and the graph just repeat each other. The yeah, the shape of the graph is repetitively the same, okay, until x is infinity. Okay, so what's happened is we call we call this from 0 to 2 pi a period. Okay, and the period of this y equals to sine x is 2 pi, because it's repetitively the same over 2 pi. Or for instance, if I say this is the line here, pi on 2, okay, if I want to know when x equals to pi on 2 plus 2 pi, which is 5 pi on 2, and your y answer should be the same. Okay, this is basically the meaning of the period, and the distance between, say, this value is the same, so the difference between them is 2 pi. Okay, and here is the period. Similarly, let's look at a cosine graph. The cosine graph has the same shape as the sine graph. They all sine wave. Okay, and of course they have a period. The period is the same, which is 2 pi. Okay, uh, the the method to determine the period of the graph is just basically find a tip there and find the other tip and calculate the distance in between, which is in this case is 2 pi. So that means as x increases to infinity, the graph just repeatedly the same over 2 pi. Okay, and the difference between cosine graph and the sine graph is their starting point. As you can see on the graph, on the sine graph, it starts from the origin here, and when x is 0, y is 0, so and ends up there when x is 2 pi, y is 2 pi. However, in a cosine graph, when x is 0, y is 1, so it starts from the point 0, 1 and goes one period and start again, which is 2 pi and 1. Okay, then it's like the cosine wave is like sh a shift version of the sine wave. Okay, and okay, and one thing when you sketch trigonometry graph is in a exam question or any question in your book, when they ask you to sketch a trigonometry graph, they will always tell you to sorry, they will always tell you to sketch the graph in the certain range, a certain domain. For instance, they will tell you to sketch a graph from 0 to 2 pi. That's mostly the case. Sometimes they ask you to sketch a graph from 0 to 6 pi or from 4 pi to 7 pi. Okay, they will always tell you the domain. If they don't tell you the domain, you have to sketch the graph all along your axis, which is annoying. And okay, and they don't do that. Just okay, and okay. Now let's look at the tangent graph. Okay, when we look at the tangent graph, tan x graph is the shape of the graph is different. Okay, but it is repetitive. As x increases to infinity, this graph is just repetitive to x equals to infinity. The, the property of the tangent graph is we have asymptotes, and between the between the asymptotes, the distance between two asymptotes is pi. Okay, so the period of tan is pi. Okay, the standard tan y equals to tan x is tan, and well, as we can see from the graph, when x is 0, y is 0, and at x equals to pi on 2, there's asymptote. So when they are when so tan pi on 2 is undefined. Okay, because the graph cannot reaches the point x equals to pi on 2. Okay, as a result, what I can say is the general property of trigonometry graph is they are repetitive. Repetitive. Okay, and they have a period. Okay, now what I'm going to in mathematics, when we're talking about trigonometry graphs, normally what we do is we draw standard graphs, because in a trigonometry graph they always repetitively, and to analyze the graph we only need to analyze one period of the graph, because after we analyzed one period, the rest of the graph is just the repetitive of this period, so they should have the same property. So normally, okay, normally we only interested in one period, okay, in one period of trigonometry graph. Okay, of course, there are different cases. Sometimes you have to well, sometimes they ask you to draw two periods of the graph and in your exam, but the idea is if you analyzed one period of the graph, the other period should have the same property. Okay, and this just makes your life easier. Okay. Okay. Now I will like you to look at some standard graphs. Okay. In math method, uh, you will learn some standard graph. Okay. For instance, the standard graph of a parabola is y equals to x squared, which is this shape. Okay, and the standard of a straight line is y equals to x, which is this shape there, x and y. Okay, uh, so in this case, the standard graph of a trigonometry graph is is short there. Okay, and this is a standard sum graph, and the domain of the graph is square bracket x belongs to square bracket 0 to 2 pi. Okay, and as we can see from the graph, when x equals to 0, okay, y, which is sine 0 equals to 0. Okay, when x is pi on 2, y, your y sine pi on 2 is 0. Oh, sorry, is 1. Okay, and when x is pi, your y, that is sine pi, is 0, and when x is 2, well, 3 pi on 2, your y will be minus 1, and here. Okay, and when your x is 2 pi, your y will be 0 again, and it keeps going. So with this kind of information, you can do with the help of the standard graph, you can, well, basically you can do some questions such as sine 3 pi on 2, you know it's 0, or inverse sine 1. Okay, reading from the graph within from 0 to 2 pi, which is from 0 to 360 degrees, the only answer is pi on 2. Okay, okay, or sine inverse minus 1, you're reading it from the graph, which is 3 pi on 2. Okay, and okay, and yeah, and the period of the standard graph is from 0 to 2 pi, and the amplitude, basically the highest point in the standard graph is 1. Okay, the minimum point is minus 1, and also this is because it's repetitive. This is reason we can previously we can solve all questions by using unicircle, because unicircle has 360 degrees. Start from with 0 degrees, you go around a circle, we have 360 degrees, and we can go around another circle which is 720 degrees, and the other